Okay, now we're interested in parabolas, which, like we said, we've studied before, but now we're going to look at them from a different perspective, kind of a more geometric perspective. So it'll probably have a similar feeling to the previous couple sections, where there'll be a focus. Although the ellipse and the hyperbola had two foci or foci, this parabola only has one focus. So maybe it might be a little simpler than the previous two sections. So that's kind of a nice section to end off on for this chapter. So okay, this section is, section 7.3, the parabola. So like I said, we're going to look at the same shape that we've been seeing a million times over, it seems like, just from a different perspective. So this little box kind of describes the new kind of version of our equation, the parabola. Okay, and this is just one of the four conic sections we talked about from section 7.1. Let's see, it looks, the shape of the graph looks really similar to what we've seen, but now all of a sudden there's a focus that's kind of within the parabola, kind of like with the hyperbola. The focus should always be within the parabola shape. But the equation of the parabola is kind of weird. So it looks more like it has a center and a radius. It looks like x minus h squared equals 4p. So 4 is always there, and p lets you know where the focus is, and then y minus k. So the point h comma k is kind of like your center, but in this case it's a vertex. So and it kind of describes it in the picture, but maybe it's a good idea to kind of make it more explicit that from this equation hk is the vertex, and then the focus. If the equation looks like this, where x is being squared on the left, notice there's a square on x, but at the y there's no square on the right. That means the focus is going to be at 0 comma p, because it should be above the the vertex. But I guess this is the new thing, that this geometric perspective of a parabola kind of allows us to now study these sideways parabolas, because so far all we've seen are these ones that open upward or downward. We haven't seen left or right. And they're not pretty if you see them in the other perspective that we've seen before. So that's the one good thing about this geometric perspective, that it makes these sideways parabolas, the ones that open left and right, a little nicer. But the vertex is still the same. It should be hk, and h you should always find, it's going to be the number inside the parentheses with x, but you change its sign. And then k, similarly, is the number that's inside the parentheses, but with y. And that one you change its sign as well. But on these ones, the focus is going to be, instead of at 0p, it's at p0. Because it should be on the x-axis instead of the y-axis. And you'll know you're dealing with a sideways parabola when y is being squared here. Notice in the equation, y is squared, not x. So it's a sideways parabola. That's how you know. But if it was x being squared like in the equation on the left, then you know it's a regular kind of opening upward type parabola or downward. Let's look at this guy. We got this first one, 1a. Find the focus and directrix of the parabola given by... Okay, yeah. Oh, sorry, and we didn't mention the directrix. Sorry, directrix. Directrix is the line, and the vertical parabola is the ones that open up and down. It's the line y equals negative p. But if it's a type that opens left or right, then the directrix will be, let's see, directrix should be x equals negative p. Okay, and then directrix and focus, they mean something geometrically. I know it's kind of a long story, but if you care enough, you could ask me or Google it. Yeah, anyway, it's really complicated and not fun, especially since this is the last time we're going to see these guys in this whole class. I don't know if it's worth going into. But okay, find the focus and directrix of the parabola given by da-da-da. So okay, I noticed the equation they gave me, y squared equals 8x. So this has y being squared. Y is squared. So it's going to be a horizontal parabola, one that opens either left or right. Horizontal parabola, which means we're kind of getting our little formulas from this area here. The focus should be p comma 0 instead of 0 comma p. P comma 0. We'll figure out what p is. and fill it in, and then the directrix should be the line x equals negative p. So let's find those guys. And then p, if you look at the equation, let's see, the kind of general equation up here, p is kind of like the coefficient in front of x, except there's a 4 in front of it. So in order to find p, I guess this is the idea. To find p, set the coefficient of x equal to 4p, and then solve for p. And the reason that works is because if you notice, let's see, I'm going to get a different color just to show that the coefficient of x, I mean, in this general equation should be 4p, but on the other hand, the coefficient of x here is 8. So those should be equal since they're, they represent the same equation. So I should be able to say that 4p equals 8, and then I'll solve for p. Let's see here. So 4p equals 8, all right. And then I think you can kind of see what's going to happen if I solve this. If I divide both sides by 4, p equals 2. So that's the part that just gives everything away. The focus then is p0, which now we know is 2, 0. And the directrix is x equals negative p, but now we know it's negative 2. So we've got the focus and directrix, and then we want to graph the parabola. So let's see, the focus, what's it called? The focus was 2, 0. Let's see, I'm going to plot that just for fun. And then the directrix is the line x equals negative 2. So there it is. And then I already know that this is a horizontal parabola, so it's either opening left or right. And then the center, I guess, not the center, sorry, I need to know the vertex in order to figure out where this thing starts. The vertex is h comma k, but h and k should be the numbers that are in the parentheses with x and y, but since in our equation that we're given in this specific example, there are no h and k, there, it's not like y minus something or y plus something in parentheses squared, and then same thing with x. There's no value, so it must be that the vertex is 0, 0. So this thing must start at 0, 0, and then it either opens left or right, but the thing that gives it away is it always opens towards the focus, because we kind of mentioned the focus should always be inside the parabola shape. Like up here, it was the parabola was opening upwards, so the focus was above it, so that it was inside the shape. This other guy, the parabola is opening to the right, so the focus should be to the right of it, so that it's inside. So the only way that my parabola is going to begin at that green point, that vertex, and have a focus to the right of it is if it opens up over to the right. Something like that. And, in this section, I think we're not too worried about how wide or how narrow these parabolas are. Don't worry about it too much. That, you might nail down in a future class, but this is just kind of getting us an introduction to these guys. So I think that's all they wanted. Let's try this other one here. Find the focus and directrix of the parabola. So same kind of thing. This one's actually also a horizontal parabola because y is being squared. Same kind of reason. So we know that the focus is going to look like p comma 0. We'll figure out what p is. And then the directrix, which they also want, is going to look like the line x equals negative p. So our job is to find p, but we can do something similar to the previous one. We say the coefficient of x should be equal to 4p. And the 4 I didn't just make up. It's because it's part of kind of the general equation over here. The coefficient of x always looks like 4p. And you could probably do that in your head, if you set 4p equal to the coefficient of x and solve it. You could have probably done that in your head. You don't necessarily have to show that work. But it looks like, okay, p is 4, so I should be able to fill that in and figure out the focus. 4, 0, as well as the directrix, so x equals negative 4. So I'll plot those points. Let's see, 4, 0, x equals negative 4. 4 zeros here. X equals negative 4 is here. And then we need to know the vertex in order to kind of figure this guy out. Let's see, the vertex. I think it's going to be similar to the previous one because I'm looking for h and k, and those are the numbers that are inside the parentheses with x. But when I look back at this guy, there are no numbers that are inside the parentheses with x or y, so it must be a 0 and a 0. If it was anything but 0, you'd see x plus something in parentheses or y plus or minus something in parentheses. This thing starts out at the origin right here, and it'll be similar to the previous one because we said it should open towards the focus. That's how I know it opens right. Parabola. Yeah, opens toward the focus, so you know which way it should open. The focus. And we'd already narrowed it down to either opening left or right because this is supposed to be a horizontal parabola. Alright, let's try this other one. They want us to find the focus and directrix of this guy and then graph the parabola, right? Yeah, okay. This one's going to be a little different though because x is being squared. X is squared, not y. So it'll be a vertical parabola. A vertical parabola. Alright, that means that the focus and directrix, they're similar but they're a little different. The focus, instead of being the point p comma 0, it'll be 0 comma p. We'll figure that out. And then the directrix, instead of being the line x equals negative p, it's y equals negative p. Because it should be now a horizontal line instead of a vertical line. But p should find a similar way. In the vertical parabolas, p should be part of the coefficient of y. So to find p, very similar to the previous two, set for p equal to the coefficient of x and solve for p. Oh, dang it. And I said y and I put x. Jeez, come on. The coefficient of y, hello. Let me do that again here. Coefficient of y. Yeah, okay, so let's do that. Let's see. The coefficient of y in this problem, oops, hello, is, I went a little too far there. This time it's actually a negative, so and then I do have to involve the negative. I'm going to set negative 12 equal to 4p. And then I'll solve for p. Divide by 4. So it is possible for p to be negative, and that's fine. I think that usually means it's going to open, the parabola is going to open toward the negative direction instead of the positive direction. Let's see, so if p is negative 3, I'm going to replace that here and here. So the point will be 0 comma p, which is negative 3. The directrix, though, I got to be careful because there's already a negative as part of its kind of formula, I guess. It's negative. But then p itself is negative, so it's a negative negative 3, which would actually be positive 3. I'm going to plot that point, the focus, and that directrix. Let's see. 0, negative 3 would be down below the x-axis. And then the line y equals positive 3 is above the x-axis. And I think this guy, it'll have a vertex at the origin again because there's no, there's no numbers inside the parentheses with x and y. So hk will be 0, 0. Because if you look back at the equation, yeah, it's not like x minus something squared in parentheses and y plus something squared, or no square, sorry. So the vertex should be right in the middle, and if I want to know which way it opens, first of all, we already said this is a vertical parabola, so it should open up or down, but it always opens toward the focus, so I'm just going to figure out, okay, it must open downward, because that's the direction of the focus. Opens toward the focus. And it always starts at the vertex, of course. Not bad, okay. Let's try this other guy here. We got something, ooh, this is really similar, I think. Let's see, you know what, maybe we should change that 16 to a positive just to change it, because this is almost too similar, I think, to the last one. The last one we had x squared equals a negative something. This one we also have the same thing. So if you don't mind, maybe change your negative to a positive just so we can see something a little different. So this one's similar because it's a vertical parabola, and that's because the x is being squared. That means that the focus is going to be 0 comma p, and the directrix will be that the line y equals negative p. I just have to find p, but we've done that before. We set the coefficient of y, so 16, equal to 4p. And it's always 4p no matter if it's a vertical or horizontal, if you notice. 4p equals positive 16. And it's positive, like we said, because we changed this problem to make it a little different than the last one. Okay, if I solve that guy, I divide by 4, I get a 4 for p. So I should kind of solve all my problems here. I'm going to put a 4 where that p was and a 4 where that p was. So focus should be at 0 comma 4, and the directrix should be at y equals negative 4. Let me plot those guys. 0, 4, okay. And then the line at the horizontal line at y equals -4 should be like that. All right. Now, as far as the vertex goes, very similar to the last 3 examples. The vertex is going to be 0, 0 because there's no numbers inside parentheses with x or y. So this parabola will start out at the origin. Here he is. And it's going to open toward the focus. And since the focus is above the vertex, it must open upward. Okay, so it opens toward the focus, so upward. There we go. Beautiful. All right, and like I said before, don't worry about how wide or how narrow it is. We'll nail that down in a future class. All right, let's see. Now we have a new objective here. Write equations of parabolas. So now instead of us trying to find facts about it, like before in the first objective they said, here's the equation of the parabola. Now you find the focus and directrix and graph it. Now they're saying, well, what if we give you the focus and directrix? Now you find the equation. So kind of the opposite of what they did before. This first one, okay, it says, find the standard form of the equation of the parabola with focus 8, 0. So we know P. P must be 8, first of all. So I know that I can fill in P with 8 in one of the original equations, like the general guys. Let me see, where were they? Way up here. Yeah, one of those equations that are highlighted in yellow. But to figure out which one I use, do I use the one on the left or the one on the right? I need to figure out if this is a vertical or a horizontal parabola. So I think what will give it away is the focus that was given, it's either 0, P or 0, P. Or P, 0. So depending on which one of those it is, I know which equation to fill it into. So this one, since it had a P, I think it was in the x coordinates, right? Yeah. Since it looks like that, that's what the focus looks like for the horizontal parabolas. The form, yeah, since this is the form of the focus for horizontal parabolas, we need that rightmost equation that we saw. It was y minus k squared equals 4p times x minus h. So what we really need to do is take this equation, the red one we just wrote. We need to fill in not only p but also h and k, and then we'll be done. Fill in p, h, k. So we know p, we figured it out, it was 8. So put that guy there. We know p is 8. But then h and k we got to figure out. I think what'll kind of give it to us is something that's, so far it's been unspoken and we haven't talked about it, but it's true. That the vertex is directly between the focus and directrix. So if you just picture where the focus and directrix are, that point in that line, the vertex should be right in the middle of those guys. So I can, either visualize it in your head or actually kind of plot it. Let's see, the focus was at 8, 0. So let's say here's 8, here he is. And then the directrix they told us was the line x equals -8. That's a vertical line through -8. So like that. So what's the point that's right in the middle of those guys? It's actually the origin. So right there, that's the one we want. That must be the center. Or sorry, the vertex. Center would be for ellipses or hyperbolas. Okay, so HK must be 0, 0. And then I think I'm pretty much done there. I'm going to fill in, okay, K was 0, H was 0. But everything else I'm keeping, because equations of graphs should always have an X and a Y in them, so I'm not going to replace those guys. It looks like Y minus K, which is 0 squared, equals 4 times P, but P is 8, times X minus 0, which is H. And I can simplify this a little bit. The left side just looks like y squared. The right side, 8 times 4 is 32. And then x minus 0 is just x. So this must be the guy we want here. This is the equation of our particular parabola that they described in this problem. So okay, let's try this new one. They said, find the standard form of the equation of the parabola with focus, yada, yada, yada. Okay, well we know that the focus should always look like, well, either 0, P or P, 0. But this one, it looks like there's a 0 in the x-coordinate, so that must mean P is the y-coordinate. But when P is the y-coordinate, we know that these are actually vertical parabolas. Because as we saw in the previous one, the horizontal parabolas have vertex p comma 0, not 0 comma p. So we know it's vertical, which means it's the equation on the left up there at the very top that we outlined. It's x minus h squared equals 4p times y minus k. And we'll fill in what we know. So if I just equate these guys, their y coordinates should be the same. So 15 should equal p. So I should be able to fill that in. 15 is p. I'll put that there. And then h and k I think are going to be similar to the previous one, because I'm going to picture the vertex and the director, or sorry, the focus and the directrix. Then I think I'll be able to find the vertex. So let's see, the focus was at 0, 15. Let's say this is 15. I'll put a point there. And then negative 15, there's a horizontal line there for the directrix. The point that's directly between them would be the vertex, which would be 0, 0. So the vertex must be 0, 0. That means h and k are both 0 and 0. So yeah, h equals 0, k equals 0. Just based on the fact that we know that the vertex should be directly between the focus and the directrix. Squared equals 4 times p, y minus k. So okay, the left side just simplifies to x squared. The right side, 4 times 15 is 60, and then y minus 0 is just y. So that would be the equation we want in this particular problem. Looks good. Okay, now what? Now we're going to finally graph a parabola where its vertex is not on the origin. So far we're just kind of practicing, I guess, but... and this box right here is the exact same as the one at the very top of this section. Just that way it's right in front of us. We don't have to keep going back to the first page or whatever. So we got one here that looks like the center, or sorry, the center. I keep saying center, because I'm used to ellipses and hyperbolas by now. Here we call it the vertex. The vertex, h comma k, is not going to be 0, 0, because there actually are values inside the parentheses with x and y. So remember, just like with the center of the ellipse and the hyperbola, you're going to change both signs. Change the sign of h and of k, both. So looks like h is supposed to be the number that's inside the parentheses with x, so negative 2, but I'm changing its sign to 2. And then k is supposed to be the number that's inside the parentheses with y, 1, but I'm changing its sign to a negative. So I know the vertex is 2 comma negative 1. And the focus we can find in a similar way to the very first problem we did. Focus, I'm going to set 4p equal to the coefficient of y, which is 4. So I'm going to, just to show where that 4 came from, I'll highlight it. The coefficient of y is here. That's what I'm supposed to set 4p equal to. Which is very similar to the very first problem we did here. And then I'll solve that. Solve, okay. 4p equals 4. If I divide both sides by 4, I'll find out that p must be 1. There we go. That means that the focus should be... Let's see, what kind of parabola is this? X is being squared in the equation, so that means this should be a vertical parabola. It's a vertical parabola. So this should be... Let's see. Should be 0 comma p for the focus. So 0 comma, and we just found out that p was 1, so that must be the guy. And then the directrix, did they ask for that? Yeah, okay, directrix. Should be the line y equals negative p. So let's see, y equals, and p is negative 1, so we're just, yeah, like we said before, we're just filling that in. We found p to be 1. So that's going here for p, it was kind of like the formula for the focus, and then also in here for p, because that's the formula for the directrix. And I think if we plot the vertex, the focus, and the directrix, we'll kind of see... Oh, shoot! I think I screwed up. I'm sorry, you guys. Shoot. Let me go back a little bit. Sorry. Here, the focus for these guys, since the center is not the origin, or the vertex is not the origin, the focus should be h comma k plus p for these types. And then for these types, it should be h comma k minus p. I'm sorry. Not that. H plus p comma k. Oh my gosh, I'm losing my mind. Ugh. And then the directrix. Sorry, that's a little different too. Sorry about that. I was in the mode of the previous objective. Directrix should be at, let's see. y equals k minus p. And then for these guys, that's okay, that was the focus. The directrix should be at x equals h minus p. So sorry about that. That'll kind of change our formulas here. Let's see, I'm going to erase a little bit. Just our little formula for the focus and the directrix. And then the directrix is a little different than we thought. It's okay. Let's fill in to our little formula guys here. So the focus should be at 0, h comma k plus p. Okay, what were h and k? 2 and negative 1. So 2 comma negative 1 plus p was 1. So just filling those in. This is 2, this is negative 1, and this is 1. So we fill those in and we get 2, 0 if we simplify that. Negative 1 plus 1 is 0. And then the directrix we said was y equals k minus p. Let me fill in what I know. K is the y value of the vertex, which was negative 1. So here we got a negative 1, and then minus p, which is a 1 also. 1. So it looks like y equals negative 2 is the directrix. So okay, I'm going to plot all those points we got. Let's see, focus was 2, 0. Let me see, where's that guy? 2, 0. Okay, and then the directrix was the line y equals negative 2. Let's see, where's that? Here. Alright, and if I did that right, the vertex should be right in between those guys. Let me see, where's the vertex? 2, negative 1. Okay, there he is. Let me plot that guy. 2, negative 1. Where's that point? 2, and then down 1. Yep, he's right in the middle, so you know he did something right. And then if you want to know which way this thing opens, it should open towards the focus, so it must open upward. So that the focus is kind of enclosed inside of it. Okay, sorry about that, you guys. I kind of messed up on that one. Okay, now this is tough. You got find the vertex, focus, and directrix of the parabola given by Alright. This one definitely doesn't look like we're used to. We want this to look more like the general equations that we've been looking at. We want this to look like, I guess since the y is squared, it must be that the horizontal type, y minus k squared equals 4p times x minus h. That's what we need to do, because I can't determine what the vertex, the focus, and the directrix are unless I make it look like this. So unfortunately what I need to do is first, I need to get the x term and the constant term over to the right side. So I need to I need to isolate the y terms first. That'll be my first order of business. Okay, so let me do that down here. As I kind of write the steps on the left, I'm going to follow them on this bottom area. It's y squared plus 2y plus 4x minus 7 equals 0. So okay, I need to move the 4x and the 7 over so that the y terms are all by themselves, because unfortunately what I need to do is complete the square with the y terms to make it look more like the general equation we've been dealing with, the y minus k squared, yada yada yada. So y squared plus 2y's on one side. Now the other side has negative 4x plus 7, or vice versa, 7 minus 4x. And the next term is I need to complete the square on the y terms. Complete the square for the y terms. But remember that if you add the magic number to the left side, we called it the magic number before, then you also have to add it to the right side. The magic number to both sides. So we kind of have to think back really far. Let's see. To find that magic number that's going to make that square be completed, we take the coefficient of y, which, okay, in this case is 2. Let's see, to find the magic number, just in case we forgot, which it's easy to do because there's so much that we've learned so far, I find half of that number, so half of 2, and then whatever I get, I square it. So half of 2 would be 1. If I square that, I get 1. That must be the magic number. That's what I want to add to both sides. So I add 1 on the left, 1 on the right. And the left side, as we've seen before, if you're completing the square, the whole point of it is it should be able to factor that guy. Y squared plus 2y plus 1 should factor into y plus 1 times y plus 1. Then the right side now, I'm going to combine like terms. I got negative 4x. The 7 and the 1 together make it 8. And the left side, of course, if you found the magic number right and you factored it right, those two factors should be the same. So you should be able to write it as y plus 1 squared, or the same term squared. So the left side kind of looks like it should. Notice it looks kind of like this, except for there's a plus in between y and 1, but whatever, that's fine. That just means k will be changing signs. But the right side kind of doesn't look right, because I'm supposed to factor a negative 4 times p, whatever p is, out of it. So the last step would be, I'm going to factor the coefficient of x out, and then it'll be perfect. And we'll be all done, and we can kind of finish this problem as normal. So that, I can see, that'll be my last step. I didn't really leave a lot of room, sorry, let's see. I'm going to erase this stuff real quick here. Or at least some of it. Maybe I'll rewrite it a little further out. We got the magic number was half of 2 squared, which ended up being 1 squared, or 1. So we got that. But then the last step will be, we want to factor the coefficient of x out of both terms on the right side of the equation. Alright, then we'll be all done. So okay, that's the last step. The coefficient of x is negative 4. So that'll be what we want. And if I take a negative 4 out, let's see, x minus 2 would be left, because you need negative 4 times negative 2 to make that positive 8. Oh, Lord, okay. Now I think that we finally have it in that form. That's not quite what they were asking for, but we needed it in that form to figure out what they want. The vertex is going to be h comma k. So I look inside the parentheses with x. There's a 2. I change its sign. K, that's the guy that's inside the parentheses with y, but I change his sign as well. So it must be a negative 1, and then the focus, well, this equation has a y being squared. This is a horizontal, it's a parabola. Okay, so that means that the focus should be at the point, let's see, h k plus p. So once I find out what p is, I can fill that in, and then the directrix should be at the line y equals k minus p. So I'll fill those in once I find p, but p we find the same way now that I've done all that work. P should be found by setting the coefficient of x equal to 4p. So the coefficient of x is negative 4. I'm going to set him equal to 4p, and I'll solve by dividing by 4. It looks like p is negative 1. Okay, sounds good. So I'll put a negative 1 for that p, and for this p. Let's see, h was 2 and k was negative 1. Let me fill those in. H is 2, comma, k, negative 1, plus p was also negative 1. Looks like that's going to be 2 comma negative 2 for the focus. And the directrix is the line y equals k, k is negative 1, minus p, but p is also negative 1. So it's y equals negative 1 minus negative 1, which is actually negative 1 plus 1, which is 0. So let me gather all that information we had. The vertex was 2, negative 1. The focus was 2, negative 2. And the directrix is 0. Y equals 0. Okay, let's figure that out. Okay, the vertex is at 2, negative 1. Where's that? 2, negative 1. Here he is. And then the focus, I think, was at 2, negative 2. Is that right? I already forgot. Yeah, 2, negative 2. So that's just 1 down from that. And then the directrix actually end up being the line y equals 0, which is actually the x-axis. I'm going to try to draw a line right on the x-axis. And that's a good sign. I think I've done everything right so far. That vertex is right in the middle between the directrix and the focus. And since the focus is below the vertex, that must mean that this thing opens downward, because I should have the focus inside of the parabola. Oh man. Okay. Alright, and then of course the the most complicated part of these problems is the applications. So the first application, they've kind of guided us along so that maybe the second one we can do on our own. Okay, it says, an engineer is designing a flashlight using a parabolic mirror and a light source. The casting has a diameter of 6 inches and a depth of 4 inches. What is the equation of the parabola used to shape the mirror? At what point should the light source be placed relative to the mirror's vertex? So it's kind of hard to picture. That's why I think they're kind of guiding us through it. It's tough. So here, what do they say? They're kind of giving us a hint. Okay. Position the parabola with its vertex at the origin. Yeah, because at this point, you haven't been given an equation. You just kind of know some information. So you're free to place this parabola however you want. And of course, placing the vertex at the origin is always the easiest, kind of simplest looking thing. I'm going to put the vertex right there at the origin. And then open upward. I mean, because you have the freedom to kind of open it whichever direction you want. I would open upward just because it's the positive direction, so I think it'll make the equation easier. And then the focus is at 0p on the y-axis, okay. Because that's how vertical parabolas work, we said before. Since the casting has a diameter of 6 inches, it extends 3 units to the left and right of the y-axis. Since it is 4 inches deep, the point 3, 4 is on the parabola. Okay, that means if I go off to 3 on the right, 4 above, that point should be on the parabola there. Okay, 3, 4. Da-da-da. So, yeah, so that means that my equation is going to be, okay, this is a vertical parabola, so it should look like x minus h squared equals 4p times y minus k. And then I can kind of fill things in. Well, h and k are 0, 0 because I placed this thing at the origin, so the vertex is at 0, 0. This is really just x squared equals 4p times y. Because, yeah, h is 0, k is 0, so they're gone. And then what we need to do is figure out what p is. That's kind of the key for these guys. If you want to know the equation of a parabola in this geometric sense, we need to find p. Find p. Okay, and the only way to do that is to use that information that the point 3, 4 is on that thing. So I guess the idea is, if the point 3, 4 is on the parabola, then I should be able to replace 3 for x and 4 for y. And then p will be the only thing we don't know. So that's the idea. I'm going to replace x with 3, so there he is. X squared equals 3 squared, okay, and then equals 4p times 4, that was y. And then try to solve for solve for p. So I'll square the 3 squared is 9. And then I'll simplify this because 4 times 4, I can multiply those to make the 16. So 9 equals 16p, which means if I solve for p, by dividing both sides by 16, I'll get 19 over 16 for p. So the equation, we said, simplified to x squared equals 4py. That's what we said a little earlier. And now I can replace p. So x squared equals 4 times, let's see, p is 9 over 16y. And then that reduces a little bit because 4 goes into 16 4 times. So this is the equation you end up with here. The light source should be placed at the focus, 0, p, or 0, 9/16. That means it's 9/16 of an inch above the vertex along the axis of symmetry. Whew, that's a lot of work. Alright, let's try that on this next one. We got, I think, something similar going on. Now that we've seen that whole process once, this should be a lot easier. So I'm kind of already getting ready. I know that there's going to be a parabola involved. I know that this is a real life situation, so I'm free to place this parabola however I want. I'm going to place it so that its vertex is at the origin. So the vertex h comma k is going to be at 0, 0. And I've made it just purposely because I like vertical parabolas. They're kind of easier for me to wrap my mind around. My focus will be the point 0, p, whatever that is. So I'm kind of getting ready here. So the casting has a diameter of 4 inches and a depth of 1 inch. So that means that, kind of like they described before, that this here, from here to here is 4 inches, and the height of it is 1 inch. But that means, what would this point be here? Well, the x value would be 2 because that's half of the diameter. Because that's, from here to here is 4. That would mean that the x value is half of that because the x value should only be from the x-axis to the right side. 2, and then the height of that point we already said was 1. So we know that 2, 1 is on this parabola. Is on the parabola. So I think that should kind of give it to us. We have, this is a vertical parabola because that's how we designed it. It should have that general form that we've seen before. this guy. But we've already said that the center, or sorry, the center. I keep saying center. The vertex is at 0, 0, because that's how we placed it. That means H should be 0 and K should be 0. I'm going to replace those guys right now. Okay, H is 0, K is 0. And I'm getting closer, because pretty much what I need to do now is find out what P is. And that should tell me a lot. Alright, but that simplifies to just x squared equals 4py. And then to find p, I'm going to use the fact that I know a point on this parabola. Since the point 2, 1 is on the parabola, I should be able to replace x with 2 and y with 1 and then solve for p. Let's see here. If I replace x with 2, that's 2 squared equals 4p times y, but y is 1. So 2 squared, okay, that's 4 equals, and then 4 times 1 on the other side is just 4p. Alright, and then I have p if I divide both sides by 4. P is 1. That means that the equation is x squared equals 4 times p, which is 1, times y, equals 4y. So since p is the distance from the focus, well, from the focus to the vertex, distance from the focus to the vertex, that means that the answer they want is P1. Shows the, what were they talking about, the lens? No. At what point should the light source be placed relative to the mirror's vertex? So that means 1 inch away. Are they talking about inches or feet? Or what? 4? Yeah, inches. Okay, they're talking about inches. So the light source, oops, should be placed P equals 1 inch from the mirror. Is that what it was? Yeah. So I think that's what they're describing here. This is this. The mirror they're going to put here. The focus we found was 1 inch above. So that's where it should be. Yeah, the focus is where the light source should be. Whew, that was tough.